Hey, everybody. Good morning, good afternoon, good evening. There's a lot of people joining us from a lot of different places. So, wherever you're joining us from, welcome and thank you for joining us today. Really excited to be here with you for class number 2 of week 3 of Startup School, our training series. For anyone who's new, my name is Erin. I lead global programs for startups at Google Cloud, and I am your MC for today's session. All right. So just to give everyone a little bit of the lay of the land, we are in week 3. We are really lucky and fortunate today to have program partner NVIDIA joining us. We will be discussing multimodal use cases and workflows for businesses. So we'll have our awesome Google Cloud speaker, Deb, present first, and then we'll have NVIDIA join us and present their content as well. So you guys picked a great session to join. So thanks again. Next week is our last week already. Hard to believe we'll be wrapping up the training series. But we've got 2 great sessions planned for you. So the first on Tuesday is a deep dive into quality, evaluations, responsible AI, and safety. And then the last class of the series will be bringing it all together. So orchestration, productization, and deployment. So if you've stayed with us this whole time, next week is a can't miss. You're going to wrap it all up, and it'll be great to have you there with us. Okay. So I know there are some of you who have, this is week 3 for you, and you've been joining us week over week, which is great. But just a few reminders. We're going to run through a few housekeeping items and things like that before we jump in. So number 1, we have our live sessions every Tuesday and Thursday at the same time each week, depending which time zone you're in. Important to know, our on-demand sessions are available if you go to our landing page. So if you go to the Startup School landing page, you can watch the sessions on demand, nearly immediately after the live session ends. So this is great. You can take your time. You can rewatch something you may have missed, or you just want to, watch again to better understand. So something to keep in mind. Number 2, you can practice what you've learned in class using the recommended Skills Boost labs and notebooks. We have the full repository and list right on the link you're seeing on the screen. So be sure to bookmark that, refresh it so that you can make sure you're seeing the latest. But again, these labs will give you access to try all of the technologies and solutions for free. You can practice with guidance. And this is the link with the full list to check out. And last but not least, fun reminder, you can obtain skills badges for completion of certain labs and courses in the Cloud Skills Boost platform. So again, just something to keep in mind as you're working through everything. All right, let's go over Cloud Skills Boost really quickly. So we'll be using practical labs as part of the training program. For those of you, again, who are joining us after the first 2 weeks, you're already probably familiar with this, but for anyone new, you can access these labs at no cost to you, but you do have to fuel your account with credits on the platform. So if you haven't done this already, you're in luck. We've got the QR code up for you. Scan that code. There are, step-by-step instructions and about what you need to do now to fuel your account. So again, scan the code on the right of the screen. You're going to follow the instructions. We have the full link there if you need it. Fill in your details. So verify your email, and then you finish the intro lab. Pro tip, you have to spend at least 6 minutes in this intro lab for it to work. And then credits will be added to your account. If you have any questions, you can email support@quicklabs.com. If you have any issues or need assistance with redemption. All right, and last but not least, let's cover some housekeeping items before jumping into today's class. These tips and tricks are just a couple of things that will help you make the most of your time in class today. So number 1, you can probably all see on your screen now, there's a chat function on the right-hand side, and then also a Q&A panel at the very bottom. So we have Google and NVIDIA experts on today. They're on hand to answer any questions that come up throughout the class. So please ask your questions in either of those spaces. We do save the last few minutes of class for live Q&A with our instructors. We'll pick the most commonly asked questions or those relating directly to the content that's covered. You can upvote the questions in the Q&A panel. So we encourage you to do that. Today's structure will be a little bit different just with the Google content and NVIDIA content. Once Deb, our Google speaker, wraps, we'll leave some time for her and for you guys to ask questions. And then we'll bring NVIDIA on stage and leave time at the end for everyone to ask NVIDIA questions. So a tiny bit different today, but same sentiment. Number 3, as previously mentioned, we are recording all of these classes. You'll be able to watch them back on demand at a later stage. You can access the recordings via the main program page. If you have trouble finding that, we also send out, email follow-ups with those links. And so you'll be able to, check your email and go directly there if you need any help. As a reminder, we won't be sharing slides, but as covered earlier, we will share links to the labs covered in class, both during the class in the chat and Q&A panel and in our weekly recap emails as mentioned. If all else fails, go to our landing page, go to the resources tab on that page, and you can find the full list there as well. So plenty of places for you guys to hopefully get where you need. Last but not least, and probably most importantly, this is a hands-on training series, and most classes do cover a lab. All of these are available on the Cloud Skills Boost platform or on our Google Cloud GitHub repository. We do share all the links with you to access both of these, so we really recommend using the class time to watch our instructors going through the lab, completing it after the session. The credits we provided will last you the full 4 weeks of the program, so you have plenty of time to do this after class. And again, if you have any issues accessing the labs, don't worry. You can email support. You can come back and try again later. All right, that's it from me. I'm super excited to bring Deb to the virtual stage to lead our session today. Welcome, Deb.
Yeah, thanks so much. Hey, everyone. So I am going to be covering the sort of first portion here, which is the multimodal use cases and workflows. So just, to introduce myself, I actually covered a session in the last quarter startup school around vector embeddings. We didn't get too much into multimodal though, so I'm excited. I'm back. We're going to get more into the details around some of the video image capabilities. So in terms of what I wanted to cover, I'm going to first start off with just really giving you some inspiration and some examples around how teams and organizations and users of these models are just starting off with what I would consider the first step, which is prompting, right? So we send some multimodal information. Maybe we send a PDF, maybe we send a video, maybe we send some music files, maybe we send them all at once, and we instruct the model to perform some sort of task for us, right? So this is, prompting in the same way that we're used to it. It's just now we're working with new formats of, unstructured data. So common sort of patterns, what we typically tend to see coming out when we start prompting is, we have an image or a video and we have some sort of question or task, right? So extraction and maybe then generation tends to be a very common piece. So, what's a fun 30-second activity I can do with my 1-year-old during bath time, and send a photo along with that prompt. So the key here is we don't just send the photo, we don't just send the image, we also need to give the model instructions for what we want it to do with this piece of information, right? So analyze this info, analyze this code, how do I declutter this space? So we're extracting and we're letting the model do its own sort of level of reasoning based off of its understanding, right, of that information. Another really common approach, just sort of with off-the-shelf multimodal prompting, tends to be taking something like, you can see here, my monthly planner, or a picture or a PDF of some tables of data, and turning that into, let's say, a structured data set. So really, you could take this and also turn it into a summarization. You could also turn it into a JSON, let's say, land it somewhere else. So you could start to turn sort of semi-structured information and turn that into. So I'm not going to play this video, but you can go look it up and send this on this link. But we also have seen now we're getting more into the video space. So let's say you have a video clip, right? In this case, there is a very rude Uber driver. and we're sending the sort of recording of their interactions. And so you can see this prompt up here on the left-hand side, detect and locate in the video. There are fare cancellation or trip cancellation, if you hear foul language, if they're eating food, Uber does not allow payment in cash, right? So, as we go through, I'm not going to spend 5 minutes watching this video, but the model is able to now address all of these different prompts simultaneously, right? So it's a single prompt with this video, and it's telling us exactly where these events are happening in this video. So we can see that it's getting the name of the rider right? It's telling us he's eating chips, kind of rude. He's canceling this trip in an attempt to kind of get a scam. He's also using foul language. So just really, bringing examples to life for you of these types of use cases, I think is just really, that's what I'm going to start off with here. We have a pretty cool demo that you can also go see. We'll send out the links for these where, we can prompt in other languages on a video that maybe they're speaking in English, and we can actually get the same output, transcription in French, right? Another pretty common use case will also be, I think you might have seen some of the research papers when we sort of calibrate and we test prompting against videos, is around this sort of idea of the needle in the haystack. So you can see for this video, we can send a prompt of when is this action happening in the video? What does the commentator say about it? Provide a time code plus image below, right? So we're sending a multimodal prompt along with the data to be analyzed. Yeah. So we can send a drawing of what we're looking for, right? And then we can also send an image. So we can see that exactly, 55 seconds in, the commentator is getting, utters and almost on one leg, and McAllister scores wonderfully well. It's also, I would say, a pretty common approach that, teams will want to take the existing data that you might have. So you might have product data, you might have data coming off of cameras or coming off of snapshots of the people are doing something going through, and actually start to turn that into product tags, right? This could be really useful for a variety of things, and what that entails is a prompt along the lines of provide a list of all the following product attributes for the main product in the image, answer in JSON for each category, use the attributes. And we can see, right, if we send it with this image, we're able to get a pretty decent response back. So this has not been fine-trained, this has not been fine-tuned or, customized specifically for like pants or waist pockets. It's just Gemini on its own already has a pretty good understanding, of this type of product information. Same thing for this furniture image, and depending on what you want, right, you can templatize the JSON and so the response and the data that you're looking to extract and get back. So by sort of templatizing it here in the prompt, we can make sure that we're sort of getting the right level of responses that we want to get. We also have a setting in Gemini when you're using the models, when you're using the APIs, you can also turn on a setting to force it to always answer in JSON, for example. So this is actually one of the settings that you could enable on the model itself when you're using this. Another example where's Marty McFly riding a skateboard at 6:05. So just because we started a bit late, I'm going to keep going. And so I've given you a few examples of sort of the power of being able to analyze, multiple videos or a lot of maybe different images and videos, and maybe we have an audio file thrown in there all at once, right? So when it comes to how much can one of these models actually start to analyze in one go, that's when we start to refer to the context window. So the context window is sort of really defined by the amount of tokens that it can handle. Yeah. And so, token is really going to depend on the modality that you're working with. So is it is it a video or is it a bunch of high-res images, right? For example, maybe it's a bunch of code. But in any case, really, we're trying to give you a sense here of the fact that Gemini 1.5 Pro, which is sort of our latest in terms of family of models, and especially within the Gemini family, it can handle right now in GA 1 million tokens. We also recently announced, 2 million token context window, which means that we can even start to process almost 2 hours of video, right? We're talking 22 hours of audio, maybe thousands of pages of docs or books, right? And a lot of images. So 6,000 images. Well, depends. So it's really, I think we're getting to a point now where it's not like we can just analyze, one short video at a time. We can really start to think bigger because we can handle so much more in this context window. So if you are interested in getting access to the 2 million context window, this is coming. But you also can contact your Google Cloud team about getting onto the private preview for it. So that was just a little bit, of a flavor from a multimodal perspective. If you are sort of really keen to get started with some of the multimodal prompting, a good place to start is if you go into the Vertex AI Studio. You'll see over here we have actually we have some pre-canned examples for you that you can actually use to get started with. So if you check out the prompt gallery, there's actually quite a few sort of multimodal prompts in here. So let's say you wanted to describe video content, extract information from a chart, things like this. Definitely a really good place to start, because always having an example can help you go faster. This is going to use some sample data, but then you can start to put in your own data, right? So definitely worth checking out. If you haven't seen it already, to get started with multimodal prompting, check out the prompt gallery. Yeah. I'm going to come back in now. So prompting, I would say, is always sort of the simplest, fastest, easiest place to start, right? So when we have our data, we're ready to get started with it. However, and as part of the sort of more advanced workflows, there are going to be use cases where we actually want to turn our multimodal data into embeddings and then start to use those embeddings and the results that they're returning, right? Along with a Gen AI model. So this can give us, increased benefits in terms of sort of, basically the quality of the context that we might be providing to the model at that point in time when it needs to go perform some sort of task. Yeah. And so, I think I had done quite a bit in the first startup school about embeddings. So I'm not going to necessarily like rehash everything about them, but just to do a quick refresh, I think when we talk about embeddings and vector search and reg, semantic search tends to come up quite a bit. And for, I think the majority of us, maybe we already probably have sort of an idea of what this might be doing, especially if you're interacting with, like Google search on a regular basis. However, what we're really referring to is going beyond sort of the traditional structure of maybe, let's just say, keywords and tabular data, right? Maybe we have like metadata, labels, and categories. What we really want to start to get to is this sort of scaled information retrieval. So if we store our information as embeddings or as vectors, then we can actually start to, store all of our either, unstructured information in a way where now we can start to use it more broadly. Yeah. So just quick refresher, but definitely check out the previous class that we did on this. The embeddings are going to build out, right, a map of the contents and the meaning. So if I tweeted about something, some topic, if I tweeted about some soccer game or something, and then someone else tweeted about something maybe similar but slightly different, maybe something about the music, are the representation of our tweets, they'd be close to each other, but maybe slightly different, let's say on the music axis, right? So, this is a simplified version in the sense that, a lot of times we're not mapping to like 3 dimensions here. We're probably mapping to like, 1,000 or something like that. But this is how we can sort of meaningfully start to organize this information and use it in a way where it's lower dimensionality, which helps the AI models also understand it and bring back the most relevant information. Google actually has published some pretty cool courses on this. So if you go to like Coursera and stuff, you can check it out. This is what we use to power our products behind the scenes from sort of, Google Play, search, YouTube. So, vector technologies, along with sort of some of our managed vector databases and vector services are quite relevant. And so, as you can imagine, also inherently multimodal as well. So a lot of the data in our products is not just text data or sentences, but also we're talking about music, audio, videos. Yeah. To sort of bring it back to something like Google search, fundamentally, search is leveraging this technology. A lot of the papers, I think, were sort of breakthroughs earlier on in the space to sort of do that super fast matching for us, right? To return the most relevant results on a web page in mere seconds. So yeah, math practice books for adults, we get the sort of new result, maybe math primers for adults. But the point is that we're actually getting the most relevant results. It's not just doing a keyword search. Yeah, it's giving us more relevancy. So yeah, I'm going to keep going here. So when it comes to sort of embeddings for multimodal use cases, you should just, I think many people are not even aware that we actually have a multimodal embeddings API. So I've included the link down here to the docs to sort of get started with it. You can also sort of, as shown on the screenshot, you can go to the model garden, and if you just look for the embeddings for multimodal, this will actually sort of bring you to the sample code to get started with the multimodal embeddings API. And I'm going to cover a notebook later that actually goes through some of that and how to use it. So just a few things to be aware of is that, you need to just sort of know that it's going to create, 1408 dimension vectors. So just being consistent in how you use those. We also have, a few other embeddings models. So I think just worth calling out that there's also text embeddings model, as well as a newly released, embeddings for text multilingual, which will then have sort of inherent support for over 100 languages, which is exciting. Yeah. Okay, so now if we kind of come back to the multimodal sort of workflow or side of this, I think, remember, an embedding gives us just the numerical representation of any kind of piece of info, right? So that could be this video, could be this picture, could be whatever, my tweet, yeah? It's going to represent them as a vector. The similarity of these is going to be sort of give us a metric of how close they are to each other, yeah? And then we can store them all together in the same space so we can use them for things like multimodal RAG, which stands for retrieval augmented generation. Yeah. So, in situations where maybe the prompting isn't getting us far enough, right? Or we're hitting constraints in terms of what we can fit into a context window, that's where potentially, some of the multimodal RAG workflows can help us. I do want to also then cover, because I think that a lot of these capabilities have been newly added to BigQuery, the fact that sort of via the BigQuery machine learning capabilities, there is now tons of capabilities to actually process different formats of data by accessing remote APIs via BigQuery. Exciting. So, you may or may not be familiar, the fact that we have a very, very tight integration between BigQuery, which is our data analytics platform, and Vertex AI, which is our AI machine learning platform, yeah? And so it means that sort of using the BigQuery machine learning interface, it gives us SQL functions that we can use to call all these different types of models, yeah? And sort of through the power of BigQuery, BigQuery gives us the capability to store unstructured information in what we call object tables, yeah? And it also gives us the ability to store things like vectors too. So we can now start to also tap into the power of distributed compute and the ease of SQL from BigQuery for AI and machine learning and Gen AI workloads, yeah? So for those who may or may not be familiar with BigQuery ML, there's a nice little GIF on the right-hand side here, which shows sort of some of the ways that you can actually start to use BigQuery ML. I'm going to hop into a demo in a minute showing some of like the vector embeddings on this. But the key point here is that as long as you have a way to access sort of the data that you want to apply the model to, and that could be structured data, so it could be a table that's sitting in BigQuery, but it could also be like an object table with images, yeah? So you could have an object table referencing the images that are stored in a Google Cloud Storage bucket, but you can create an external reference to that table in BigQuery so that, let's say you create a connection to Gemini in BigQuery, you can now actually pass prompts to those images by using a few lines of SQL, which is really powerful. So just to give you a sort of view of, and I'm not going to cover all of these today. So, I'm only going to cover maybe like two of them. There are a lot of these different BigQuery ML functions. So for example, the ml.transcribe is going to give you the ability to call the speech AI API, right, to process that and give us the outputs. Well, we've also launched a new integration with the Doc AI API for processing documents directly. I'm going to show you some of the vector embeddings. So you can generate embeddings now using BigQuery. So this will create a remote connection to our embeddings model on Vertex. So let's say you have the text that you want to embed or the images that you want to embed. You could now just run a, hey, BigQuery ML dot, it'll be like ML dot generate embedding function on that table. And then that could be a really good place to create and store your vectors like for ongoing use cases. Yeah. So there's quite a bit here that goes beyond just the sort of traditional machine learning and predictive ML, which is also covered via the like classification, regression, clustering models, but now lets us tap into all these other different types of processing multimodal. And like I had mentioned before, let's say you have a bunch of images in a bucket, you can start to actually process those using BigQuery with Gemini. So let's say we wanted to do entity extraction, right? Or image analysis. What that actually looks like is first creating a remote connection to the Gemini vision model. Yeah? So you only have to do this sort of once per model endpoint that you want to access. So it's not something that you would need to run every single time. Rather, you need to set up that connection once, and then you can continue to use that model. So what this is doing is by saying sort of create model, so this is the name, with this remote connection, you're then specifying that you want to connect to this Gemini Pro Vision endpoint. Once this endpoint is created, you can then call it, yeah, by using the name of that model. So I can see here that the model name is BigQuery ML Tutorial Gemini Pro Vision Model. And this select star is saying run, right? So run this prompt on this table. So this is an image table. So this is an image object table. So I'm storing images. Their metadata is stored as the rows in the table. And I can say, what is it as the prompt? But you could say the prompt as anything you want. So this is going to go through now and apply that prompt to every single image, that's stored in that table. So if I hop over into BigQuery, and you just give me 1 second, I'm also going to quickly just show you some of the vector search and embeddings capability as well within BigQuery. So the other sort of option that you can start to play around with is sort of once you've created some of these vectors, you could actually use sort of the vector search function. I realize this is probably quite small for people because of my screen, so hopefully this is better. You can start to see the here vector search capabilities. So now this is performing a vector search function from directly within BigQuery. So there's a couple things going on here. You can see, right, that I'm generating and embedding on the fly, right? So this is my embeddings model. And then I'm selecting sort of, a row or whatever to send as my sort of, so this is just hard-coded text, to send as my input. And that's then running this query against the, against that underlying table. So this is going, if you run this, it's going to run an actual vector search and return the results with the distances. And just to show you also what that actually looks like from a modeling perspective, if I go to this data set, inbound logistics, I can actually see that I have the embeddings model. So I already used the remote connection to create that model. And if I click on it, I can actually see, okay, this is a remote connection to a text embedding gecko model, right, on Vertex AI. So that's how easy it is to be able to start to use some of these models from directly within BigQuery. So now, if I come back here, just to sort of round out that point, is that not only can we call Gemini for vision to do multimodal analysis and prompting for us directly within BigQuery, we can also use it to create our embeddings, store our embeddings, and then even perform things like vector search. Obviously, if you have pretty low latency requirements in terms of sort of what's being returned as part of that vector search, the vector search performance in BigQuery standalone might not be enough. And that's where you then may need to start to look at something like syncing it to, an online serving capability. So here what's highlighted is Feature Store, but we have a lot of other options like AlloyDB might be a good database for that. We also have Vertex Vector Search as well. So a lot of different options, even once you create those vectors to then serve them in a low latency setup as well, prediction wise. Okay. And then, sort of the last piece of this I'm going to cover is sort of a quick bit around multimodal RAG. And so when we talk about retrieval augmented generation, so with some of the previous startup school videos last quarter, I had some pretty in-depth coverage around sort of reg and best practices when designing reg systems. But what we're really going to focus on here is some of the the techniques, and I'm going to show you some examples, right? Resources available to you to get started with multimodal reg. So in this example, right, this is just sort of a basic reg workflow. We're going to sort of start with our ingestion and our parsing, right? So this is sort of the creation of those vectors. So the pieces of information, maybe we're chunking out a PDF, maybe we're just putting images in as vectors themselves, whatever that looks like. And that's when we start to get into this sort of the retrieval part of the system itself. So in the system, we need to store these vectors so they're available for retrieval. And then we have a question come in. We then get the returned chunks or the returned relevant results. Those get passed as context to the Gen AI model, which is actually trying to perform the task at hand. And then it has to try to figure out what to do with that. Yeah. So in these series and in the notebook that I'm going to show you in a minute, this is going to, split our PDF into chunks. And in this case, in the demo, those chunks are actually pieces of text and images that are extracted out of a PDF, right? So it's multimodal in the sense that it's not just, a document, it's also individual line items and pieces of the text and the information, the metadata about those chunks, right? So what page, what page did this image actually come from? Because that's very important when we're doing RAG so that we can actually cite where we got the information from. And that can all get returned back to the LLM when it's doing its response synthesis. So I'm gonna hop over now to here. So we have a few quick labs and links that I have on sort of the last slide after this as the wrap up, which we will be sharing out afterwards. I would recommend before jumping into the multimodal RAG notebook here that I'm showing, if you have not done sort of any work with the just getting started with vector search and with embeddings, I would definitely recommend just doing the sort of vector search and embeddings, getting started quick lab first. I think that will give you a better grounding, no pun intended, to the sort of what's happening in here, because this is sort of kind of assuming you have a bit of knowledge around why you would be making embeddings. So I would start with that lab first before jumping in to some of the multimodal stuff. So and if you are very comfortable with vectors and embeddings, then maybe you skip that one and you just go to the multimodal. So we're gonna sort of initialize. In this example, by the way, too, we have a few different Gemini models. So I would say sometimes Flash can give you better performance, but might be weaker on some of the reasoning tasks. However, Gemini 1.5 Pro tends to be more quota constrained. So as you are going through and you're working with this, if you do start to get some quota limits and issues, then I would say work with Flash. So you probably might get some quota issues with 1.5 Pro. You can raise the quota limits if you're in your own GCP project environment, but if you're on a quick lab environment, I would say either work with Flash or Provision. That'll hopefully resolve those issues. So in this example, right, this one's going to be importing some helper functions. So these helper functions are going to browse the PDF and make sure that we're storing the relevant metadata. And when I say metadata, I mean like the page on the PDF, right? The chunk number, things like that, so that those are also stored for the model. And this sort of pre-processing part here is pretty key. So this function, as it goes through and it processes all of the pages of the PDF, what it's actually going to be doing is extracting your text and your image metadata from your document, and then it's going to load it into these two data frames. So we'll have a text data frame and an image metadata data frame. Yeah. So this is sort of, I would say, consider this as sort of some of the pre-processing to then giving this context to the model. So if you are going to run this notebook, by the way, it can take a few minutes to run. So that's expected. So yeah, we're going to give it, some image description prompt. Feel free to also change this as you're working through. I'm going to scroll through this because it takes a while to process. And then there is an option to load some of the pre-computed metadata, by the way. So if you do want to do that, feel free. It might be faster. but you can't change the prompt then because obviously it's been already extracted for you. So if we take a look here, right, at what kind of chunks are we going to be giving to the LLM for it to perform the tasks at hand, you can see here I have things like the file name, right? So there's a technical paper here. I have the page number. I have the actual text, right? The embedding, chunk number, chunk text. I didn't mean to do that. I scrolled. It's going to take me down to the bottom again. But yeah, so we'll have that text metadata page, and then we're also going to have a similar table with the image metadata, right? So because we are also extracting out the actual like tables and the images and the charts from the PDF, we're also then going to have our image metadata. Yeah. So we're going to have some, image description. So we're actually, this is a bit cheeky. We're actually passing the image back through to Gemini to generate some better metadata about it, which is nice. So you'll have the Gemini generated sort of like helpful description, because that description about what's actually in the image might be really useful for getting that back in the context of a RAG application to then try to answer a question or perform some sort of task. So then we have the actual embedding combined with the metadata, right? So we have the file name and the page number. What's the image number? So this page has multiple images, things like that. Yeah. So now we have all that information, and then there are quite a few helper functions in here. So definitely worth taking a look at what some of these are doing in terms of, that similarity search, helping us print out various citations, right? Maybe we want to see what are the similar images to this image. I really like this example because it starts to bring to life sort of different ways that you can start to interact with this information in a multimodal way. Here are some examples, right? So let's start with a basic text search. Yeah. What are the various Gemini medical benchmarks? So its performance relative to other models. We can then run the sort of helper function, get similar text from query. So this is now sort of matching, right, my query with all of the text embeddings that I had previously chunked out to give me the results. So I can see, right, that there is a citation. It has a pretty high relevancy score, and then it's giving me the actual chunk. So this is the chunk from that embedding, right? And then we can also start to get things like, the safety, harm, and categories. In the interest of time, I'm going to keep going. So maybe we do something like search similar images with a text query. So this is where maybe we need, some of the information that might be locked up in a table or another image format. Yeah. So in this case, we're going to use the multimodal capabilities. So the goal here, right, is find an image similar to the text query. So, and let's print out the citation. So what are the various Gemini medical methods shows performance relative to other models? We then use the get similar image from query, and we can actually see it's returning this table, this chart. So this chart was chunked out, right? And we can actually see here are the most relevant charts or images, because these were also separately embedded to answer the question, right? As you can imagine, these are also the types of, this is the types of results that will then provide more and more context back to the model, right? So when we do answer the question and explain results with the given images and questions, you can use these images also as like citations. So, and if you wanted to upload an image yourself, yeah, so searching images with an image, right? Something like that. We upload our own chart, find me something more like this. You can do similar image, in the same pattern as well, right? So we upload this. This is a hosted image, technical report. Give me something very similar. So with that, I think we have maybe about like 5 minutes left for questions. But yeah, I will. Yeah. So I'm happy to take some questions now, if that makes sense. Yeah.
Hey, Deb, thank you so much. That was awesome. Before we get to questions with you, I'm going to just go over the Google for Startups Cloud program really quick. So we'll give you a few minutes to grab water, and then we'll come back. We'll invite you back on for some questions. There's a few. All right, everyone, that was awesome. I'm going to let Deb catch her breath just for a minute or two, as mentioned. And while we do, I wanted to draw your attention to the Google for Startups Cloud program. So as you're, completing and going on this exciting Gen AI learning and training journey with our Google Cloud experts and our program experts, I am very confident that you'll want to try the products and solutions that you see referenced throughout the training series, many of which Deb actually covered today. So if you're a startup, you can apply for up to $350,000 in cloud credits via this program. And that means you can start building Gen AI solutions for your business right away. So we have various support offers for every different stage of startup, including tailored programs for AI first and Web3 companies. You can scan the QR code that you see on screen or visit the link on the screen to learn more and to apply. We've also pinned this in the Q&A section below the video if anyone needs access. And yeah, so with that, I will invite Deb back on. Like I said, there are a few questions that maybe we can cover with you, Deb, live before we let you go.
Yeah, so if you want to just share my screen quickly too. So I think there was a question in there around batch pipelines with multimodal. So Gemini supports batch predictions. So I just wanted to flash up this link because this might be a more efficient way to send some of those like multimodal prompt requests from like a non-latency sensitivity perspective. So I would definitely start with batch predictions from a Gemini perspective when you're thinking about sort of batching those types of pipelines. And then there's a question around for the multimodal embeddings. Should the content be in the same language or can it translate prior to embeddings? So you do not need to run translation prior to turning it into an embedding. I think the caveat here is always that, like, at least in my sort of practical experience, it typically tends to depend on sort of the language in terms of whether or not how good it is as sort of getting out of the gate and going between them. But I've actually worked on some projects from a translation perspective where just the regular text models are able to embed tons of like historical translations and turn those into a RAG system. We also have a multilingual text embedding model specifically for those types of use cases. But in the event where you have like a video, I don't think you would need to necessarily run it through like a dubbing model first to necessarily run it as an embedding. But something that you could look at doing is like first pre-processing it with something like Gemini to then generate, a different version or a different language or translation or something, a description, metadata, more metadata about that in another language. And then you could embed all of that together as well, as long as you sort of started with the same metadata. So there might be something around there with Gemini for pre-processing to help sort of improve some of the reasoning or the logic around it, but you wouldn't have to do that. And then I think there was a question around how large are the vectors or multimodal embeddings. So those will be like the 1048 ones. So if you go to Vertex AI and you go to the model garden, it's usually useful to just sort of check here in terms of the embeddings API. So if I go to embedding here, you can see we have this sort of, if you go to like text or multimodal, this will also give you the dimensions of that multimodal embedding model. So you need to actually be just aware that it's going to be working with, it's going to be a 1408 dimension vector each time. Yeah. So typically it's not usually the size of the individual vector that's going to have, give you some considerations. It more would be how many total vectors are you looking at storing, right? In terms of just making sure that you have enough space, latency, things like that for serving them. And then there was a question. So can Vertex give me answers based directly on information stored in BigQuery? If yes, how does it work? But the only way to build an agent that would treat it from BigQuery. So I think what you're probably getting at there is a question around sort of how do we start to ask questions about tabular data sets that are stored in BigQuery using like natural Q&A from an LLM. So in terms of the integration that I had been showing before, what I had been showing was the ability to start to apply a generative model to the data that is stored in BigQuery. But the example that I think that you might be referring to there is more of a what we call like text to SQL or like a data Q&A type of task. So there are a couple of different ways that you can start to address that type of, if you share my screen one more time, this is the last question, I promise. Couple of different ways that teams are addressing this. So the first one would be using something like function calling. And this is an example of a sample app that specifically does this kind of like talk with BigQuery, whereby we actually make specific queries to BigQuery accessible as functions that the LLM, that Gemini has access to, so that it can go and say, okay, I execute this function, I get this response back. So it's basically just like an API. And then I do something with that information. So this is one way that you could look at it. So this whole app is available on our generative AI GitHub. So you could actually take a look at that one as a first option. And then the other sort of side of this is, let's say that there's just not enough, you just cannot design all of the possible queries that someone is going to ask, right? And you're like, so that's not going to work for me. I want the LLM to dynamically generate some SQL, execute it, and then bring back an answer based off of the response. So in this case, this is kind of when we would talk about something like data Q&A, where you would chat with your SQL database. So this is where I do a conversation, I ask a question about this, and then behind the scenes, right, we've given enough context to the database. And as you can imagine, there's actually a lot going on behind the scenes here, as indicated from the architecture of the diagram, to then be able to enable the Gemini model to actually answer that question using its own generated SQL, get the query response, and bring that back. So also worth checking out this GitHub, this repo here too, for those kinds of use cases. And with that, I will head it back. And thank you very much for having me.
Thank you so much, Deb. That was awesome. Cool. I am super excited to welcome the NVIDIA team. We've got Mike, Tom, and Sujit all joining us on stage, on virtual stage. So welcome, everyone. I'm going to hand it off to you for your portion of this session and the content. I know everyone's really excited, and I'll see you guys back on at the end for questions.
Yep, sounds great. Appreciate it. It's going to be very difficult to try to top off from what Deb just did. So thank you again, Deb, for that great session. So in the essence of time, we're going to get right into it here. From an agenda perspective, we're going to kind of take a slightly different approach from what Deb just highlighted, going the Gemini route. Gemini is a phenomenal, amazing model, especially for multimodal use cases specifically. But we're going to kind of talk about on the NVIDIA side and the Google side, how you can take a slightly different approach. So if you wanted to kind of build this on your own, and if you wanted to kind of curate this in a slightly different manner, we're going to walk you through how to kind of build this. And the way that we're going to do that is through a couple of different stages and almost like a little bit of a life cycle. But we're going to talk through just briefly what the NVIDIA Google Cloud partnership is, how to actually deploy LLMs on GKE, for example, using a few different workflows and technologies. And then we'll close a little bit on a specific quick lab that we have, and kind of share with some best practices and guidance on how to deploy that lab for you all. We won't have the time to actually do it here in the class today, but we're really recommending and hoping you all can try it out in the afterwards. So with that, just to spend a quick moment, for those that may not be super familiar with the Google and NVIDIA partnership, it's been a 8-year plus partnership between Google and NVIDIA, and it's been just an amazing journey for us. How it really works is in a couple different categories, and it's easiest to kind of look at this left to right, no matter where your left or your right is from a screen orientation perspective. But today we partner with Google in collaborating and providing Google Cloud with the GPUs to power specific instances. So Google Cloud takes chips that we sell them, integrates them, and builds them to these awesome infrastructure instances. Specifically, the bigger ones today are the A3 instance that we really recommend for large scale training and tuning, and then the G2 instance, which is great for tuning of smaller models, some of that 7 billion parameter or below level, even doing inferencing for some language models as well. It's a great use case. So we partner together on the infrastructure side. Then in the middle column there is where we spend a good chunk of our time. So on the NVIDIA side, many of you might or may not know, like we focus not only on the infrastructure part, but actually developing software and SDKs to make that developer experience as seamless as possible for when you're using GPUs, and essentially give you the tools to let that GPU handle multiple use cases for training, inferencing, analytics, whatever you want to do. And our view, and I'm a little bit biased, and I think Google does this the best out of all the providers, is we have a very integrated and successful integration, I would say, throughout the entire Google Cloud stack. So no matter where you want to use GPUs, whether it's Vertex AI, GKE, Dataproc, Dataflow, we have not only a GPU infrastructure story, but a GPU optimization and software story to go with these integrations. So no matter where you want to go do your GPU compute, we have some really nice and unique integrations on the NVIDIA side built in with Google. And then the two other areas are a little less critical today, but we do have availability for some of our products on Google Cloud Marketplace, that being the NVAI Enterprise piece, which we'll talk a little bit on here in a moment. And then as well as a product soon to be launching here called DGX Cloud, which is a managed environment where NVIDIA will help you train your model specifically within our Google Cloud tenant. And then lastly, Google and NVIDIA have partnered significantly on the DeepMind front, partnering and co-creating, co-optimizing, I should say, not creating, co-optimizing the Gemma model for GPUs and the entire family of Gemma models, whether it's PolyGemma, CoGemma, and some of the other solutions. So that's in a nutshell the actual integrations today. Now we're going to walk you through how to go and kind of build your own LLMs on GKE, for example, from scratch. And there's kind of a couple different models, a couple different ways we can look at this. So on the right, you kind of see the BYOM, which is bring your own model, and we would actually say also build your own model. So if you wanted to build your own GPT T5 transformer model from scratch as an organization, we're going to walk you through the different steps that you can do to still do that and accomplish that on GKE. We'll also walk you through on the left side, if you just wanted to deploy models from an inferencing perspective and didn't want to necessarily set up your own TRT or Triton LLMs inference server, if you didn't want to tune that model or train that model, if you just wanted to infer that model on a GPU very seamlessly and quickly, we have the NIM route, and I'll be touching on that specifically. Sujit will be touching on the NEMO framework and GKE story, so the tuning and training of either your own model or foundational models, and then Tom will wrap with deploying Triton and TRT LLM. Triton's been around for quite some time, and we created the TRT LLM backend about 6 months ago to help us scale with the language model demands and needs from an inference perspective. And Tom will walk you through some of the best practices for the Quick Lab. As a Quick Lab we have specifically focuses on the inference layer, and that's where we see our customers having the most challenge, the most demands, is around the inferring and the latency and performance of those language models. So quick step, though, we're going to focus on the first step of this journey. Let's just say you just want to do inferencing and do it very quickly for a Llama 3 model, a Gemma model, another foundational model. You just want to launch it into your app or your service, and or you just want to do some evaluations. Well, NVIDIA at Google Cloud Next and a few other conferences, Computex within the last week as well, has been talking quite a bit around NIM, and that's our NVIDIA microservices place, essentially, at the end of the day. And what these microservices are a few different things. They're really focused for right now on the inference layer. So whether you're trying to infer specific NVIDIA models like MolMIM, which is something we built for drug discovery and molecular dynamics, and let's say you wanted to deploy a Llama 3 model out of the gate using NVIDIA GPUs, using the right backends, not having to worry about all the drivers, setup, configuration. If you just wanted to deploy models, NIM is the right route for you to explore. How you access NIM is through NVIDIA AI Enterprise. So we are in what we would call direct access, kind of like a private preview right now, still of many of the NIM microservices. However, most of those initial products are coming GA now, which is great. And we're slowly releasing more and more NIMified models, if you will, into the AI playground that we have. So, but you do access NIM through NVAI Enterprise. That can be secured through Google Cloud and consumed through your Google Cloud contracts that some of you might have. And the NVAI Enterprise license essentially unlocks you to leveraging the NIM route to market. Essentially, it's a pre-built container and Helm charts, and essentially model nannies and carries over that model that you want to infer over to GKE, and it includes the drivers, the setup for Triton and TRT LLM, or even a potentially other inference package if you need to, and essentially lets you deploy that model very, very rapidly on GKE. Again, not super customizable. You're not going to be setting up different KV batching, different ensembles. This is really great if you're just looking for like a single model and just getting it out the door very quickly. And it's essentially a subset of about 30 or so models today that we have, but we'll hopefully grow into the 40 to 50 range that are NIMified, if you will. And then just from a Google Cloud perspective, we've had a lot of great success with NIM already out of the gate, as Sujit and others can attest to. But one of our favorite references that we had is from Gia, who's the chief AI officer and president and founder of LiveX.ai. And Gia and her team came to us with a challenge around, wanted to find the best optimal performance. They had a very small team of individuals and data scientists and ML engineers, so they couldn't necessarily go and build our Triton or TRT LLM inference servers from scratch. So they wanted the fastest way possible to deploy GPU-based inferencing. And what I love about this is literally we got up and running with NIM that afternoon with Gia and her team. The only thing we were literally waiting on was GPU quota. And that's more of an NVIDIA problem than anything else, right? And a market problem, I would say. But what I loved is not only did her and her team see immediate performance improvements, but literally they got up and started and running that afternoon. And I'm one of the biggest Triton fans out there from an NVIDIA perspective, but it certainly takes sometimes a little bit more than an afternoon to build your inference pipeline and your Triton pipeline, from scratch. So NIM is a route that's available through DA access today. For anyone that would like to try it, again, we will include it in the links. But that kind of concludes more of the specific kind of as a service section on my side. From now on, Sujit and Tom are going to kind of walk you through the life cycle of a model. Let's say you want to build your own or tune an existing model and then get into the inference pipeline. Sujit and Tom are going to walk you through that now.
Cool. Thank you, Mike. So this is the second part of the discussion, and we're talking about how you can customize. This is really building pre-training large language models using NEMO framework on a GKE. So to set some stage here, I will in this slide I'll give an overview of NEMO framework itself. So NEMO is an end-to-end, very comprehensive cloud-native framework for building and deploying generative AI applications. And it comes with 4 to 5 different processes. I'll walk them through each one of them. The first one being data curation. In data curation, as you can imagine, all of the model training and tuning relies on high quality data set. So as long as you have means and mechanisms to dedupe the data, to extract, filter, I think that's something which lays a very solid foundation when it comes to have a very curated data set that you can use, downstream. The second portion of this is the optimized training. And when it comes to training, NEMO really efficiently utilizes all of the GPU resources across tens of hundreds and even thousands of nodes across. And that helps with really leveraging a lot of the distributed training with advanced parallelism techniques, and this enables a lot of the maximum throughput and significantly minimized training time, which are some of the key KPIs that you look at. The third portion of this is around model customization. So once you have your foundation model trained, it is important that you have mechanisms to train it using different techniques, be it around fine tuning, supervised fine tuning, RLHF, P tuning, a whole bunch of options that are out there. So NEMO gives all of these capabilities at your hands so that you can kind of customize it for your needs. And the fourth portion of this is around the deployment. So NEMO integrates seamlessly with the NVIDIA's Triton inferencing server to really accelerate a lot of the inference process, delivers a lot of cutting edge accuracy, low latency, and high throughput. NEMO allows for secure and efficient maintaining privacy of data. So if you're having very strict constraints around the data privacy, NEMO gives all the tools by which you can kind of guard the data and honor some of the data privacy requirements that you have. And overall, right, kind of the summary of NEMO framework itself is it's a game changer for a lot of the enterprises looking to leverage Gen AI applications, and it empowers businesses to drive innovation, optimize the operations, and secure a competitive advantage in the market landscape. Next slide, please. Perfect. So this slide, I want to introduce kind of the confluence of how GK is set up and how it's used in the AI ML space, and how really NEMO framework sits on top of it, just for be it for building, training, and deploying workloads. So if I start from the bottom up, you have the Google Cloud infrastructure, which is across, I think as of today, maybe 40 regions, each region having minimum of 3 zones. So you have that global reach that's out there. The layer above that is GKE itself, which gives you access to storage, access to compute, networking, all of the goodness that you need for training AI ML workloads. That's where it fits in. So if you look at the lower part, right, where you have compute, GKE, and storage, from the compute standpoint, it gives you access to all of the latest NVIDIA GPUs, be it from H100 all the way, even the previous ones, with the A100, L4s, all of those you have access to. From the storage standpoint, you have access to file store, access to cloud storage, wherein you can have file-like operations on your objects itself. And then on the networking standpoint, we are having all the networking bandwidth to achieve high performance that you need for training your language models. The layer above that, where you see the multi-instance and time sharing, these are really capabilities of GKE, which will help. In case of the multi-instance GPU, you can partition a single NVIDIA GPU in up to 7 instances, so that each have their own high bandwidth memory, cache, and compute cores. The time sharing is where you have multiple containers that share a single physical GPU attached to a node. You can more efficiently use your attached GPUs, primarily to save costs. Then from the center all the way till the right, you have options like access to local SSDs. You have GCS fuse, the GPU direct TCPX, which is to provide all the networking bandwidth that is needed for training, and the GVNIC, which is the Google Virtual NIC interface, to make sure you're getting the required throughput. And the layer above that, which is more on auto scaling and things around placement policies, just to make sure all the capabilities, some of the requirements around making sure you have nodes which are sitting close to each other so that the data transfer is much more quicker. You have reliability itself within GK that could use. Those are the things that you can definitely tap into. And back on the software stack, where you see Q, which is a Kubernetes, it's a native scaling job workload management. So if you're really constrained for a lot of resources, you can submit your jobs to the cluster, and depending upon the availability, your training workloads are executed. So you really don't have to kind of wait on it. Once the job is ready, you'll get notified and you can start using. And the layer on top of that, where you see Nickel, workflows, frameworks, libraries, this is one of the main reason you can see that GK definitely thrives in this space, because there's a lot of community adoption, a lot of open standards which are available. With that, you can notice PyTorch, the NVIDIA Triton server, and Nemo framework sit on top of that. So once you set up this entire infrastructure, you can kind of scale this across different teams, like different small, medium, large size teams. You can kind of slice it across different use cases to build, train, and deploy. Next slide, please. All right. So we have a public facing GitHub repository, which is a Google Cloud Platform / NVIDIA Nemo on GKE. It's a completely end-to-end walkthrough of how you can pre-train a large language model. In this case, we are using the Megatron language model as an example. It sets up the entire infrastructure on Google Cloud, backed by NVIDIA H100 GPUs. And this repository is providing a Terraform script that you can set up the reference architecture, which I'll be showing in the next slide. It has the GK cluster backed by A3 nodes, file store, GCS, pretty much all the things that are needed from a compute, storage, and networking standpoint. You can set up in your own project. You can use your own data set. In this particular example, we are using the publicly available Wikipedia data set to pre-train the language model. Next slide, please. All right. This slide gives an overview of the reference architecture of how it's kind of set up. There are about 5 VPCs. The main VPC is the host VPC, and from then on you have about 4 other VPCs, which are needed to give the required networking bandwidth. So that's why you have those 4 GPCs. From then on, from a networking standpoint, so that was on the networking standpoint. When you look at the compute point of it, right, this is set up in a regional cluster, but you could always set up even like a zonal cluster for pre-training your language model. So there's a single GK cluster which is having 2 node pools. One is a default node pool, more for the common GK related things like DNS policies, updates, and other related activities. And the real node pool is the GPU node pool, which is backed by the NVIDIA H100 GPUs. And in this particular case, we are setting up about 2, but you can scale it all the way probably up to 16 or even more. So that's the GPU node pool, and each of these nodes are having about 16 SSDs that you can attach to for any kind of file transfer that you need. That's where it kind of fits in. And then you have Q over there, which is set up on the cluster for all of the job workload management, which I was talking earlier. So that's on the compute standpoint. On the storage, you have file store, you have GCS itself. GCS will host the training data, and the file store, which is NFS file store, for retaining most of the logs. And then looking towards the right-hand side, you have the AML stack, which is you have Colab. You can primarily access the cluster, you can submit your jobs and related things. And then you have TensorBoard, which is where you can view your logs primarily for accuracy, validation, and that will give you an ability to retrain any other things that you need to be doing. The lower portion of this is more of the cross-cutting services on the GCP side, be it around IAM for security, firewall rules and policies, persistent disk, which have been used, and Terraform primarily for the provisioning aspect. And on the far right-hand side, right outside the gray box, is the NVIDIA's NGC catalog, the NVIDIA GPU catalog, which is a repository of all the containers, models, images. So we would primarily be doing a pull of the NEMO framework image from the NGC catalog, setting up in the GK cluster, the containers up and running, and you can submit your jobs. So that kind of gives the technical overview of what it takes to set this up. Before I transition it to Thomas, the key three takeaways are look at NEMO framework. It's on the GitHub NVIDIA NEMO. That's the page you can look at. And you can look at GKE itself, which is on the Google Cloud platform, which if you look at GitHub, Google Cloud Platform, AI and GKE, you'll find a lot of ready-made examples that shows how some of these GPUs are being leveraged for training language models. I guess those are the main things I had. Over to you, Tom.
Thanks, Sujit. Hi, everyone. So the last step in our journey that we're covering today addresses the use case of once you've built or tuned an LLM using something like NEMO framework, what's the best way to serve that model at scale? Next slide, please. When looking to serve a large language model, there are a few challenges today that we typically see our customers face. The first one's really finding a way to actually go and deploy an LLM in real time while also being cost effective. The second one was, with the ever-changing landscape, how do you stay ahead of this constant stream of new models and techniques to go and deploy and serve these models? And then the last one is really, how do you balance between performance, latency, and ultimately the cost to actually go and serve these models? So to help address these challenges and really help you get the most out of your NVIDIA GPUs, next slide, please. When serving LLMs, NVIDIA and Google actually come together to provide a scalable inferencing solution using 2 pieces of technology, TensorRT LLM and Triton, running on Google Kubernetes Engine. So TensorRT LLM, or TRT LLM for short, is NVIDIA's LLM-specific compiler that helps you achieve faster performance and lower latency during inference for your LLMs. And then Triton Inference Server, as Mike mentioned, is NVIDIA's long-term inferencing solution that provides you with the standardized way to deploy and serve ML models across every workload. So both of these technologies come together really nicely to offer you an optimized inferencing stack that can be deployed and scaled directly on GKE. So let's go into a bit more detail. Starting with Triton, this is, as I mentioned, it's NVIDIA's preferred inferencing solution that enables you to deploy your models at scale. and it has a few really key benefits that you get out of the box. So from one standpoint, it supports any ML framework such as PyTorch or TensorFlow. So this really kind of simplifies the inferencing deployment pipeline for your data science teams to really kind of have a simple way to actually interact with that deployment. Also supports across any type. So meaning model ensembling, which is essentially a technique where you can stitch together multiple ML models together into a single inferencing pipeline, really provides a powerful way for you to kind of go optimize and serve a low latency solution. And then lastly, it really supports at any scale. So it supports not only streaming and batch, but also supports across any hardware types such as GPUs and CPUs. And it also gives you the ability to kind of prioritize your resource allocation across your models, across your infrastructure. So ultimately, Triton is giving you that flexibility to really use the best ML framework to build your model, while also providing a predictable, standardized deployment pipeline to serve for inferencing, which we see a lot of DevOps teams really, really liking. Now, with LLMs, to get the most out of Triton, NVIDIA brings you TRT LLM, which is NVIDIA's open source library that offers a way to optimize inferencing performance on top of our GPUs. It's built on Faster Transformer and TensorRT, which is NVIDIA's general purpose deep learning compiler. And really prior to TRT LLM, LLMs were prohibitively complex to optimize and deploy. So luckily with TRT LLM, we make that easy using a simple Python API for defining, optimizing, and executing these LLMs for inference and production. With that, you're gonna have the ability to kind of customize the model parameters, reduce the memory footprint, increase throughput, and improve the inference latency for your LLMs. It also includes optimizations such as in-flight batching and FP8 data format, enabling you really to get that high performance while also reducing the cost that it takes actually to deploy and serve these models. So, for example, a test that NVIDIA did with Llama 2 70B yielded a 2x performance, 2x improvement in performance, while also reducing the cost to serve that model by 3x. So you're really kind of stitching these two pieces of technology together to really get not only better performance, but also a more efficient solution when actually going and trying to deploy your LLM on GKE. Lastly, when both these things come together, both these two pieces come together, we really obviously like it on Google Kubernetes Engine. It provides you that flexibility to scale to meet your customer demand, while also providing you that kind of efficiency to kind of control your costs. Next slide. So moving into a bit more of a reference architecture around this and kind of reading from left to right. To implement this, all you really need to do is configure your LLM with TRT LLM using its Python API. And then really deploy it on Triton directly onto a GKE cluster that has a GPU node pool. From there, you can access your served model from any of your applications, leveraging the power of GKE to scale up and down to meet the demand. And it's pretty impressive because all the complexity that we've seen customers face when actually trying to deploy and serve these LLMs, we've actually packaged up into TRT LLM and Triton to really make it simple and get you that kind of optimized LLM for production. So a really cool example of this, next slide please, was some work that we did with Google when we actually leveraged this exact same deployment technique to accelerate Google's open model Gemma this past March. So with their launch, we launched the ability to take Gemma and actually compile it with TRT LLM and then serve it on Triton. And this is actually the same exact lab that we're actually providing for you today, which is great. So you're going to be able to get hands-on experience to kind of run through the same deployment technique that we partnered with Google on with their Gemma model. Next slide, just to kind of walk you through a little bit in terms of what we're offering you with this lab. So first, it's pretty standard. You're going to set up a GKE cluster with the GPU node pool. We're actually bringing NVIDIA's L4 GPU with that. So that's the type of instance that you'd actually go and deploy this model with. The next piece around that is you're really going to just pull down the Gemma model and wrap it with the TRT LLM compiler. As I said, this is pretty simple to do with the Python API that's provided. There are some parameters in there that obviously you can look to tweak later on, but we predefine those for you so that it's easier to get started with. The last step is once you have that kind of compiled Gemma model, you actually go serve that optimized model directly onto Triton, which is running on GKE. So Once that happens, Triton will actually serve up that optimized model, and you'll actually be able to send some prompts directly to the model using some simple curl commands. And each step in this lab, you'll work through how to get to that endpoint and try it yourself. So overall, the lab takes about an hour to complete. We're super excited for you to try it. And if you have any questions, please raise them, and we'll help address. Passing it back, I believe, to Mike.
Yep. So as Tom mentioned, we certainly love everyone to try out the lab as they have the time to do so. Take you roughly, I'd say, between 45 minutes to hour, 15 minutes. Give or take a couple of steps here and how fast your internet connections are. And then I would say we'll be sharing a bunch of these different links as well. But the NVIDIA Inception program is an amazing program for startups to leverage. We kind of merged and married a lot of those two resources with Google Clouds for Startups back at Google Cloud Next. So there's a lot to leverage out of both of those programs. And it really is that like peanut butter and jelly type combination as far as being able to get credits and support and even access to us for us to collaborate together. And then again, if interested, you can just apply for NIM access through the DA link that's in there as well. And again, this will be sent to you. So with that, I think we will pass over to Erin.
Awesome. Thank you all. That was great. I'm going to give you guys now just a quick breather, maybe grab some water. I'll cover just a few kind of housekeeping items and reminders, and we'll do Q&A. There's lots of great questions for you all in the chat. Cool. So with that said, let's see, are my slides up? Yes. Okay. I'm just going to reiterate to try the NVIDIA game that the team just mentioned. The link is there. The QR code is there. The access code is startup-school. If you complete every activity in the game, you can earn a badge, which is super fun. And you can collect badges all across Quick Labs by completing different games. So collect them, show off your skills. The lab will be available for, I believe, 3 to 4 days. If you have any issues, please email us in terms of access or anything like that. But we're really excited for you to try it like the NVIDIA team mentioned. All right. So number 2, really important. Please share your feedback and your thoughts with us. This is the QR code to our survey. The link is also there if you need to paste it directly. Again, we're always looking to improve. So your feedback is really, really valuable to us. I promise we read it, we share it, and we try and make improvements. So if you guys can just take about 3 minutes to fill out our form, we'd really appreciate it. And then last but not least, a quick reminder, week 4, last week of Startup School starts on Tuesday, June 11th, same time, so 10 a.m. Pacific, 1 p.m. Eastern time if you're in the US. So just friendly reminder, Tuesday's session will be a deep dive into quality, evaluations, responsible AI, and safety. We've got 2 great Google Cloud engineers who will be presenting the content. So it's a can't miss session. Don't want to miss that one. Great. All right, let's invite the NVIDIA team back on. Awesome. Okay, we had a few questions, as you guys probably saw from the chat. So let's get started. This one is from Yingding Wang. What is the minimal GKE requirements to deploy with NIMS?
Yeah, and Jay, I'll have you maybe take that in a second. But first step would be to make sure that you're actually in the DA and have submitted, right? So you do need that NVAI enterprise license. And we do have a trial for that as well. So if you don't have an enterprise license today in your current contract, you can apply for just a 90-day trial license. And then we are in that process of actually building a sample, but Sujit's actually got hands-on experience deploying NIMS on GK, so I'll let him make a quick comment on any other initial best practices.
Sure. Thanks, Mike. Yeah, for NIMS on GKE, as long as you have access to GPUs, and we are talking about like L4 GPUs, that's a good place to start. And with that, I think the memory requirements and even like the storage requirements, they're fairly achievable. There's not like a huge bar to kind of cross. So I think GK cluster, the node pool, access to even a single L4 GPU should be good enough for you to get started.
Awesome. All right, let's keep moving here. So let's move to, I'm not sure how to pronounce this name. Last name is Nabila. But question is, can you explain how the containers share the GPUs dedicated to the cluster? Are the GPUs shareable across the cluster nodes?
Sure. So I can take this one. For the GPU sharing strategy, there are about 2 to 3 strategies. The one I think couple which I covered around multi-instance, and the other one around time sharing. So when you set up the cluster itself, be it using the console or using gcloud command or Terraform itself, you can specify whether it is a time sharing or a multi-instance, and you can specify the slicing of the GPU. Is it like 5 gigs that you want to share, or is it like 10 gigs? Depending upon that, you can partition the cluster, and all the nodes in that particular cluster can access the GPU. So very much possible. In fact, there are walkthroughs that show how to set this up. So I can probably put that, I can share that.
Awesome. Thank you. I think we have time for one more question. This is a good one. This one is from Dayananda Valal. Apologies for any mispronunciations today. Okay, do we need NVIDIA AI Enterprise license to try the NeMo examples?
Yeah, so the nice part is you do not, right? So Sujit Sample is completely easy to use, completely open source, free to use. That being said, as Tom was kind of walking through Triton and TRT LLM, we do have customers on Google Cloud who do still purchase an NVIDIA Enterprise license to support them, even if they want to go the build it themselves route with Triton and TRT LLM. That NVIDIA Enterprise license does unlock a few different things. So it does give you direct access to NIM, which is awesome. But more importantly, it gives you a couple of other things. So it does give you security patching, CVE scanning for our software and containers, and then gives you direct 24/7 access from a support perspective to NVIDIA. So with that license, it really covers you for a multitude of different things. If you want to use NIMS, great. If you want to use Triton in a production deployment and you want to have all those enterprise features and that additional support from NVIDIA directly, that NVIDIA Enterprise is a great thing to leverage.
Fantastic. I think that's all the questions we had. I know it's always nice to get some time back, so happy to do that today. But thank you three for joining us. It was a really great session, covered a lot of great content. There's some really nice comments in the chat that I can see. But thank you guys so much. Hopefully everyone who's listening live, we'll see you next week for the last week of Startup School, and hope everyone has a great weekend until then.